Welcome to Unit 2, Equations and Inequalities, Lesson 2, where we're talking about variables on both sides, or equations with the variables on both sides. In multi-step equations, we learned how to work with equations that had either distributive property or combining like terms, but mainly the simplification was going on one side of the equation, either the left side or the right side, but you were really only simplifying one side. Now we're dealing with equations that now will have variables on both sides of the equation, and how do we handle having x's both on the left or on the right? So let's go ahead and get started. The first two steps to solve an equation that have variables on both sides are exactly the same as multi-step equations: distribute when necessary and combine like terms. Remember that an equation is such that has an expression on the left and an expression on the right. So what you want to think about when you think about these first two steps is that you want to simplify each side of the equation. You want to simplify each side, so simplify the left, distributing and combining like terms, simplify the right, distributing and combining like terms, of the equation first. Once both sides have been fully simplified following these two steps on their own accord, on their own, then we will move variables to one side by zeroing one of the variables out. And I'll show you what I mean by that. By zeroing one of the variables out, because there will be on multiple sides. And then last, we're going to solve for x. So let's do some of these together. In number one, if we take a look at the left expression and the right expression, we don't see distributive property. I don't see any like terms on the left side or the right side, so there's no going to be combining like terms. So we're going to jump straight to taking care of moving the variables to one side. So again, I don't see distributive property here or here. I don't see like terms here. I don't see like terms here. Notice how the equal sign separates these into two of their own expressions. So now we're going to move straight to step 3, moving the variables to one side. And I'm going to do that by zeroing one of them out. So I'm going to choose 5y just because. You could choose whichever one you want. But I'm choosing 5y. I'm going to zero it out by subtracting 5y to both sides of my equation. Notice how my equation separates my left from my right side. Zeroing this out means if I subtract 5y from 5y, I get 0. And 0 minus 8 is still minus 8. So I've zeroed out by subtracting 5y. That gives me a balance over here, 3 take away 5, of negative 2y plus 12. Now I have an equation that is equivalent to this equation, but with only one variable on one side. So now I can work towards isolating that y by subtracting 12, zeroing that out, and I get negative 2y is equal to negative 20, and then I can divide both sides by negative 2 to get that y is equal to 10. Now keep in mind, you could take that answer of 10, plug it back in for y, follow the order of operations on the left and on the right to see if you get equality. Now let's look at number 2. Again, looking at the left-hand side of the equation, I don't have any distributive property or combining like terms. Looking at the right-hand side, I don't have distributive property or combining like terms, but I do have variables on both sides. So let's zero one out. I'm just going to choose negative 6x. The inverse of negative 6, the additive inverse of negative 6x is positive 6x. That will zero it out, which means I have to add 6x to the other side to keep the balance in the equation. So my new equivalent equation is 14 is equal to 12 minus 2x, because negative 8x plus 6x is negative 2x. Now I'm going to start isolating x. Keep in mind that since x is multiplying to negative 2, dividing by negative 2 should be my last step. So subtract 12, that zeroes out. 14 minus 12 is 2 is equal to negative 2x. Don't forget that minus does belong in front of the 2. Divide both sides by negative 2 to get that x is equal to 2 divided by negative 2, or negative 1. For number 3, I have 7k is equal to 3k minus 36. No distributive property on the left or on the right. In number 3, I do have 7k over here on the left by itself, so it makes sense to zero out the 3k and bring that inverse over here. You could zero out the 7k, that's also fine. So I'm going to show you both ways. Let's first zero out the 3k. Minus 3k on both sides. Now that I've zeroed out 3k minus 3k, I end up with negative 36 on the right-hand side and 4k on the left-hand side. Divide by 4 to both sides to get a final answer of k is equal to negative 9. So I'm going to do this problem one more time. And I'm going to do it again to show you that you're still going to get the same answer if you choose to zero out the 7k. So if I zero out the 7k instead by subtracting 7k to both sides, remember that 7k minus 7k is 0. Now I actually have to show that 0 because I need a number, I need to see something on the left side, and that something is 0. So I end up with 0 is equal to negative 4k minus 36. And remember, 0 is still a number. So now I'm trying to get k by itself. Add 36. Now I've got 36 is equal to negative 4k. Notice how we're back to the same thing. Divide by negative 4 to get a final answer of k is equal to negative 9. So it doesn't matter which you choose to zero out. Just remember that if you did choose to zero this one out, you have to show that there's a number here and that number is 0. So right now I'd like you to pause the video and try on your own numbers 4, 5, and 6 and answer the questions provided. Do your best, and remember that we're going to review these in class, and try your best to see if you can figure them out on your own, given the information that you just listened to and worked through. Now we're going to move to number 7. And number 7 is different from the examples that we previously did. How is number 7 different? Yes, the left-hand side of the equation has the distributive property. So we must simplify the left side before we can start moving our p's left and right. So we start by the distribution of 3 into the parentheses to get 18p minus 3 is equal to 11p minus 45. Now that we've completed the distributive property on the left side, we are good to zero out one of the variables, either the left or the right. So I'm going to go ahead and zero out 11p by subtracting 11p to zero that out. And we end up with 7p minus 3 is equal to negative 45. And you should be able to finish this problem from here and get an answer for the value of p. Now looking at example 8, if I draw the line to separate down the equation, separate my left and my right side, you notice that the left side has the distributive property and the right side also has the distributive property. Plus I think we're going to be combining a like term there with that plus 4. So let's go ahead and do the simplification. This is going to be 8w minus 2. That's going to be my left side of my equation. The right side of my equation is going to be negative 10w plus 30 plus 4. Now that I've distributed, I got one more step on my right side to simplify fully, which is to combine these like terms. Bring down my left side. Now I have distributed both on the left and the right. I've combined like terms on the left. Now that I'm done distributing and combining like terms, basically I'm done simplifying the left and the right. Now I can proceed to take care of my variables on both sides. So I'm actually going to zero out this negative 10w by adding 10w to both sides. That gets me 18w minus 2 is equal to 34. And go ahead and finish the problem to get the value of w. So I would like you to try 9, 10, 11, and 12 on your own, but I want to show you what I have set up here for you. I've highlighted the distributive property happening in each equation that must happen first. And naturally, you will also combine the like terms on that side of the equation if they have any, which they'll definitely have some here. They'll have some here as well. So I want you to try 9 and 10. And I also would like you to try 11 and 12. But a couple notes. I highlighted here the distribution of this minus sign into the parentheses, so be careful there. And I've also highlighted this distribution And reminded you, do not subtract those because you must distribute first. In number 12, you have distribution twice on the left-hand side. You're going to be distributing the 8 and the -2. You're going to have a lot of work to do on this left-hand side before you can start zeroing out variables. So make sure that you are distributing first, if you have it, and combining like terms on your side, on each side. These things must happen first before you can start solving and zeroing out, or zeroing out and solving. So try your best on 9 through 12. In conclusion, this video was on Lesson 2, solving equations with variables on both sides. We reviewed the steps to solve the equations with variables on both sides and connected that to solving multi-step equations, as these also have multiple steps. And we discussed about how we distribute and combine like terms on the same side to simplify the left or the right side of the equation. Last, we'll be moving variables or zeroing them out to be able to take one variable from one side to the other, rebalance the equation so that we can solve for that variable. A very common mistake, so be careful, a very common mistake that students make with these kinds of equations is they think that zeroing out happens on the same side. That is incorrect. That is very, very incorrect. Keep in mind that if you're operating on the same side, you are combining like terms. You are combining those to make a simpler expression on that left side. Now, when you're trying to take a variable from one side to the other and rebalance so that your x's are all on one side, that's when you are zeroing it out to shift it from the left side of the equation or the balance to the right side of the equation. And doing that allows you to rebalance the equation and operate with one variable so that you can solve for that one variable, because you cannot solve an equation with more than one x. Hence, we isolate x, so we need x alone. I hope that that made sense, and I thank you for listening and learning with me.